Hello again everybody, thanks for tuning in. So this is the third lesson on the normal distribution for Year 13 Edexcel A-Level Maths, obviously the statistics part of the course because we're doing the normal distribution. So far we've used the calculator to calculate probabilities given a certain value observed for a normal distribution. Now we're going to have a look at the opposite way round, where we can actually work out a certain value which would give a percentage point on that normal distribution. So whereas before we worked out the percentages from a value, now we're going to work out the value from a given percentage probability. So before we do that though, I've got a few questions for you to get you started and in the right frame of mind. So here they are, questions 1, 2 and 3. Press pause and try these on your own, see if you can remember how to do them based on what's come before, and when you're ready to see the solutions, press play and then we'll have a look at how to do these questions together. Assuming you've done that and had a go, let's have a look now at question number 1. So for question 1, Phil wants to investigate if there is a relationship between the test scores for his English and mathematics for the students in his form group. So his form group do English and maths, wants to see if there's a relation between the two. He samples 12 of his students' maths and English scores and finds the product moment correlation coefficient for maths and English scores is 0.4762. Stating your hypotheses clearly, test at the 5% level of significance whether or not the PMCC for a student's maths and English scores is greater than 0. In other words, let's test if there is evidence of positive correlation. You may use this massive table on the right, which gives the percentage points for 0 correlation. So first of all, we need to spot how many students he's sampled. So it does say quite clearly he's sampled 12 students. So because he's sampled 12 students, that means the sample level is 12, so we're looking at this row here. Now because he wants to test if there's a positive correlation, because we're wanting to see if the PMCC is greater than 0, it's a one-tailed test. We're not simply testing for correlation, where it could be positive or negative, we're looking to see if it's a positive correlation greater than 0. So it's a one-tailed test, and it's going to be 5% level of significance. So from that, we know we need to be looking at the 0.05 column. So we're looking at this column down here. So where they cross is our critical value. So the critical value for this is 0.4973. But I'm getting ahead of myself. It does say in the question to state your hypotheses clearly. So H0, we always assume for testing if there's correlation for the PMCC. H0, we always assume that there's going to be a correlation of 0. So H0, we're assuming that the population correlation between maths and English is 0. Whereas the alternative hypothesis, H1, we're going to see if the alternative hypothesis that there is a positive correlation is true. So that's our hypotheses. Now, observed, he's got a PMCC of 0.4762. That is less than 0.4973. So because 0.4762 is less than 0.4973, and I'll let myself enough space, which is a bit silly, because that's less than 0.4973. What we say here is that therefore we accept H0. Not enough evidence to suggest correlation. And I'll show you how this would look on a graphic, just so hopefully it makes a bit more sense in terms of picturing what's going on. But unfortunately, we have to accept H0, no correlation. In terms of graphically what's going on, this is what we've got. So here are critical points for rho, which is the population correlation. 0, no correlation. 1, perfect positive. -1, perfect negative correlation. Now, the critical value is 0.4973, which is here. So anything more extreme than 0.4973, we'd be saying almost definitely, yeah, it's looking like there's a really strong correlation. But because 0.4762 isn't strong enough to make us doubt H0, because it's not within the critical region, we therefore reject H1, or to put it a different way, we accept H0. This isn't strong enough to make us think actually there is correlation. Let's have a look at warm-up question 2. We've got this discrete random variable, big X, with the following probability distribution. So from values 1 to 5, we've got the probability that the distribution takes each one of these small possibilities X in terms of K. Show clearly that the value of K is 20 over 29. We just need to remember the basics, even going back to GCSE, which is the sum of all these probabilities must equal 1. So from X being 1 up to 5, that will sum to 1, because the sum of all probabilities for any one event, as you know, needs to add up to 1. So therefore, if we add up all of these fractions, K over 2 plus K over 3 plus K over 4 plus K over 5 plus K over 6, that all adds up to 1. Because it's a show that question, we can't do everything on a calculator. We need to show some sort of mathematical understanding. So what I'm going to suggest we do here is we factorise out a K from this side. So if we just take this and factorise out the K, then I'm just going to have 1/2 plus 1/3 plus 1/4 plus 1/5 plus 1/6. And that equals 1. So now what we can do, we could use the calculator to find out what the value of this fraction is, 1/2 plus 1/3 plus 1/4, all the way to plus 1/6. So let's just do this here now. So what this is going to give us is 1/2 plus 1/3 plus 1/4 plus 1/5 plus 1/6. We get 29 over 20. So K multiplied by 29 over 20 equals 1, because all of this thing here in these big brackets, that added up to 29 over 20. Therefore, final step, K must equal 1 divided by 29 over 20, which gives us 20 over 29. And we're going to use question 2 to do question 3 for the next warm-up question. So let's now have a look at the third and final warm-up question. So for the third warm-up question, we've got here that the random variables x subscript 1 and x subscript 2 are independent and both have the same distribution as big X from question 2, that should say. I do apologise, that should say question 2. Very slack, I do apologise. From question 2. So find the probability that x1 minus x2 equals 2. Give your answer correct to 3 significant figures. So if I just recall what we had from warm-up question 2, we had this, where k had to be shown to be 20 over 29. So now we've done that, we can actually work out numerical values for each of these probabilities by just subbing in that k is 20 over 29 and working out these probabilities numerically. So if we improve on this table by inputting that k is 20 over 29, we'd get this. So these are the probabilities. Now what we need to do is think about how it could happen where the probability of one minus the other gives us 2. Well, x1 could be 5 and x2 could be 3, because 5 take away 3 would 2. So the probability, oops, I'll change that to a black colour, probability for x1 minus x2 equals 2. That's a probability x1 could be 5 and x2 could be 3. or, so plus, could be the probability for the first observed x is 4, and then the second observation of x is 2, or finally, it could be that the first observation of x is 3, and the final one for x2 is 1. At this stage, you might be thinking, why is he doing the ands in red like this? It's because, even going back to GCSE, and with probability will almost always imply we're going to multiply probabilities together. So probability that x1 is 5 is 20 over 174. So this here is 20 over 174. I'm going to multiply that by the probability that the second observation is going to be 3, and that's 20 over 116. Or it could be that the first observation is 4. That's got a chance of 20 over 145. So I can multiply that by the probability that the second observation is actually 2, which is this probability 20 over 87. Wanted that in black as well, not that it probably matters to anyone else apart from me on the planet, but such is my slight OCD. Must be annoying for you, I'm sorry. Anyway, and then finally, it could be the probability that the first observation is 3, which is 20 over 116, and then I multiply that by the probability that the second observation is 1, because 3 take away 1 would give us 2 as well. So the chance of it being equal to 1 is 20 over 58. Damn colours. 20 over 58. Okay. So now it's just a case of working this out very carefully and taking your time with the calculator so that you don't make any mispresses. So I'm just colour coding in where these values came from. x1 being 4 was 20 over 145, x2 being 2, 20 over 87. Again, I've got a slight addiction to colouring stuff in. Anyway, so let's get on to this now without me talking about colouring in anymore. So the first thing we need to do is 20 over 174 multiplied by 20 over 116. Or it could be a case of 20 over 145 multiplied by 20 over 87. Or finally, we could have 20 over 116 multiplied by 20 over 58. Just a quick check to make sure these are typed in absolutely fine. That looks good enough to me. So press equals, and we get this. Press S arrow D. So to 3 significant figures, it's 0.111. And that's warm-ups completed. So we can now have a look at the main part of today's session. So today we're going to be looking at the inverse normal distribution. So for a given probability P, you can use your calculator to find a value of A such that the probability that X is less than A equals P. Now, this function is usually called the inverse normal distribution function, and I'm going to show you how to do that using the below steps for the ClassWiz calculator. Okay, so first of all you need one of these. So first of all we need to press it on, and then after that first step, which is essentially step 0, step 1 we press menu, then 7 to enter distribution mode. So what we're going to do here is press menu. As you can see 7 there is distribution mode, or you can scroll to it then press equals. So, second step. Then once you've got that menu, we press 3 to enter inverse normal. So, like you could see on mine here, the third one down, inverse normal, so I press option 3. I then have this menu, which I'm going to explain now. So, where it says area, you type in the p-value for the area you want as a decimal. So, for example, let's imagine I want to find what value would give me a 90% probability. So what I'll do there, I'd enter 0.9. So I'm going to do this here. So 0.9. So what point on my normal distribution, if I leave the standard deviation as 1 and the mean as 0, what value along this curve would give me an area of 90% of the curve from that value all the way to the left? So the final step, what we need to do is just simply press equals to find that value of A. So if we press equals here, what I get is 1.28155168. So what that's shown is that we've calculated that there's a 90% probability of x taking a value of 1.281 or less for the normal distribution, which has standard deviation of 1 and mean of mean of 0. Okay, so what we calculated here is as follows. So we've essentially just worked this out. If I sketch on my curve, the bell curve like so. In our example, it was normal, mean 0, standard deviation of 1. We wanted to work out which point on this curve would give us a 90% probability. In other words, what value here would make this proportion of a curve 0.90, 90% of the curve, and we've just found that it's 1.28. So that is actually what's going on, what we're calculating. So we worked out here that that must be 1.28, correct to 3 significant figures anyway. That's what this inverse function is doing. It's telling us what point will give us a certain probability we need. It will become clearer when we do some worked examples, so let's have a look at some. So first of all, worked example 1. We've got x, which is normally distributed with a mean of 20, standard deviation of 5. Find the following probabilities. So the first one, what's the probability of x being less than a? If that's 65%, what must a be? So all these are similar. What I would always suggest is to sketch the curve. So here's some which I've pre-drawn. So for a, we're wanting to find 65% of the curve which is to the left of a. We're after this sort of thing here. So what we're wanting is this. So we need to find a, which is here, so that all of the curve up to the point A, from the left to this point A on the right, is 0.65. So all we need to do here is to follow those instructions I mentioned earlier. So we're going to press menu, 7, 3 for inverse normal. Now we type in the parameters. So we want on the area this time to be 0.65. So type 0.65. Now for this distribution, the standard deviation is 5, so sigma needs to be 5. Press equals, and the mean, mu, is 20. So we type 20 for the mean, press equals, and press equals again. We see that a must be 21.93 to 2 decimal places. So for the first one, a is 21.93. Now for b, we want the probability of x being larger than a to be 0.3. So x is on the larger side of a, which is on the right hand side. So we're looking at something a bit like this. There's a, and to the right of a is 0.3. We need to reframe this with the inequality symbol facing the other way. So we need to think of this as the probability of big X being less than this value of a. Well, if it's a 30% chance of being more than a, that means over here must be the other 70%. So the probability of x being less than a must be 0.7. And this bit here is actually what we use the calculation based on. So again, we go back into the calculator. So it's menu, option 7, option 3, in case you forgot how to get onto it. Now we want to type in an area of 0.7. The standard deviation is still 5, the mean is still 20, so press equals. We then get that a this time needs to be 22.62. And the last one is slightly trickier, but I shall explain. Here, we've got x sandwiched in between two different limits, between 17 and a, and that probability needs to be 0.4. So again, just picturing it out, we've got to have two limits, and it's about 40% of the curve. So there's 17 to the left of 20. I'd imagine that a is to the right of 20. So what could this be? So just taking what we have here for C, we can think of this in terms of two separate inequalities. The probability of x being between 17 and a, that's the same as the probability of x being less than a. Now because these are continuous variables, I can use this symbol and these symbols interchangeably. So anyway, this inequality is the same as x being less than a, which is all of this curve down here, including this bit at the tail. So it's all of it less than a, apart from this bit here, which we don't need. So it's all of that apart from the probability of x being less than 17. So that's equal to 0.4. So all I've done here is I've reframed this and rewrote it in this way. Okay, this is the same as that. So now what we can do is we can rearrange this. So therefore we can say the probability of x being less than a, add this to both sides, that's the same as the probability of it being less than 17 plus 0.4. So we can actually work out now, using the standard normal mode, which we did in the first couple of lessons, what the chance of x being less than 17 actually is. So just to recap from last time, what we can do is press menu 7, normal CD now. So the chance of x being 17 or less, the upper limit is 17. There's no lower limit, so remember, just type in a hugely negative value for the lower limit, so it just encompasses everything. And the parameters, we've still got the standard deviation is 5, and the mean is 20. So press equals there, we get 0.2743. So 0.2743, I think it was. Yep. Plus 0.4, that gives 0.6743. So I'm trying to find the value for A, which gives a proportion of a curve of about 67% from there down lower. So now I can use the inverse normal function. So now I've taken this and I've reduced it to trying to find the probability of 0.6743. So as you can hopefully see now, I've now got it into the form, which is the same look as the other ones we've done before. So it's the same look exactly, just a different number. So now I can use the inverse normal, like for part A and part B. So we do menu, option 7, option 3, and now our p-value is 0.6743. So I type in 0.6743, press equals and equals again, these parameters haven't changed. I get 22.62. 22.26. So my value of A this time is 22.26. Let's have a look at the final worked example. So worked example 2, a company manufactures rivets to a specified diameter, big D millimeters. The diameters are normally distributed such that D is normally distributed with a mean of 24, standard deviation of 0.1, due to tiny inconsistencies in the manufacturing process. Nothing is truly identical, not even identical twins, I bet you know. So A, B and C, let's think about 3 of these different parts of the question with 3 different diagrams. So here they are. So first of all, given that 75% of the rivets have a diameter less than D, find the value of D. So what it's saying here is there's D, and all of the stuff on the left-hand side of D, all of this bit of a curve, should come to 75%. Okay, so all of this bit here needs to be 75% of the curve. So breaking it down into the type of question we had from worked example 1, we're essentially trying to find D such that the probability that D is less than this little d is 0.75. So we go menu, option 7, option 3. We want the area here to be 0.75. This time the standard deviation is 0.1, so type 0.1 then equals, and the mean here is 24. So press 24 and equals, press equals again to generate the required value, and we get here a value of 24.067. So D, little d, is 24.067 millimeters. I've given it to an extra decimal place because these values are very close together because of this tiny standard deviation. For B, we want the interquartile range of diameters. So the interquartile range means we've got a 75% point over here. So that's going to be 25% of the curve left. And the lower quartile over here, again, will leave us 0.25 in that tail. But if you think about part A, we've worked out that D is the upper quartile already, because that's a 75% point. So D is the upper quartile. So D, 24.067. We also know that the normal distribution is symmetrical. And so if that's 0.067 away on the higher end, then the lower quartile will be 0.067 below 24. So the lower quartile, 24 minus 0.067, this bit here will give us 23.933. So for B, the interquartile range is the upper quartile, which is 24.067, minus the lower quartile, which is 23.933. And if you calculate this, 24.067, can't even type, minus 23.933, you get 0.134. So 0.134 millimeters. That's a pretty tiny standard deviation. That's because they're being manufactured to be incredibly accurate. Finally, C, find the 90th percentile in plainer English, like work example 1. That just means we need to find a D, such that the probability that D is less than D here is 90% of the curve. So we're trying to find D such that all this is 90%. I won't bother colouring it in. I think I've coloured in enough so far. So I'm that to be 0.9, in other words 0.90. So this is actually fairly standard. So we just go to menu 7.3, you know the drill by now hopefully. So area now I need 0.9, the standard deviation is 0.1, mean is 24, press equals and equals again. We see that the required diameter, which is at the 90th percentage point, is 24.128 millimeters. So the 90th percentile is 24.128 millimeters. And then finally we're done. So it's now your turn to try some of these. So if you turn to page 46 and 47, exercise 3C, try questions 1 to 4 and then 6 through to 9 to get decent at these and used to this inverse process. As ever, each time we do a few questions, check them regularly, make sure you understand them, and if you're not sure, please let me know and leave a comment in the comment section. So thank you for joining me, thank you for listening. Do please subscribe and like, and I'll hope to see you around soon. So take care until next time. Goodbye for now.